Swayam Prabha. Digital India. Educated India.
Okay, in our introduction session we saw a very high level overview of what we are going to be doing in the next 12 weeks. To start with, we are going to be looking at the pre-processing as the first step. So, any corpus that is given to you, you need to really look at what kind of corpus that is. We need to understand the domain in which the corpus is available. Without understanding the domain, it is not easy for you to do any of the task, especially in the pre-processing. You need to really know what you are going to be doing. Okay, every task requires different sets of pre-processing steps. Okay, so first is about creating the corpus. Creating the corpus is very simple. Just start collecting all the relevant documents in one folder and then either create it in the binary form or some form and then make it available for you to process it. So, make it machine readable. Nowadays you do not have to really worry about the corpus if you really want to do certain experiments. Those corpus are available, especially if you look at various APIs, they provide certain corpus for you to play with. Okay. And then we need to do certain processing, pre-processing, to make sure that the text is suitable for our application. So, what kind of processing that we do in the text, we will talk about that a little later. So, again as I mentioned, understanding the problem is very critical in terms of choosing the pre-processing step. So, we will show a few examples and then see why I am talking about this. Okay. And you can say that pre-processing steps are very unique to a given problem. So, every problem is different and every problem requires a different sets of pre-processing steps. If you do not do the processing well, I think you are going to be losing a lot of lexical content that will result in very poor application value. Okay. So, this is one of the most critical aspect in the natural language processing. In many cases, it is about 30% of the application generation. So, if you have about 5 months of job or 1 year of job, 30% of your work would be on the pre-processing side. Okay, it's very crucial step. Okay. So, I am not going to be talking about certain application that you may have to use or the API that you may have to use to do the pre-processing. I am going to be assuming that you know those. Okay. For example, regular expression. Okay. So, you may have to read it yourself if you do not know this and understand how regular expressions can be used to pre-process text or extract some information from the document or replace certain values using search and replace mode and so on. So, the basic steps involved are, one is tokenization. Tokenization, as I mentioned earlier, is about splitting the text into words, right. And then the second step is normalization, and then third one is the substitution. Okay. So, you probably may not have substitution in many cases, but certain pre-processing certain applications require substitution as well. Okay. So, we will talk about each one of those, okay, and what they are. So, this normalization is about, I mentioned earlier that if you have by so these two will be converted into by, or in some cases suppose if you are solving a problem, physics problem, where the speed is mentioned as and then the normalization step requires you to convert this into meter per second. So, you need to be able to read this, understand this, and then convert the unit into this, and appropriately change this number into the required number for meters per second. So, this is useful in certain cases. This may not be useful in every application that you are dealing with. Okay. And this is where the substitution, the km per hour will be substituted by meter per second, and then the numerical value also would be replaced by the appropriate value here. So, that is where substitution comes. Okay. Or in those cases, for example, if the time is represented as 5 seconds, and this is in document 1. In document 2, t is represented as 5s. In document 3, it is represented as t equal to 5 sec. So, for you to normalize this, what you do is you pick up some standard representation of seconds and then convert each one of them into that standard representation. For example, the standard representation for second to second to is as some notation that I am using. Okay. So, all would be replaced in the standard form. So, you normalize it and then substitute this using the standard notation. Okay. So, these are the 3 operations that you would normally find in the pre-processing steps. So, we would be using something called as case folding, where we convert all text into lower case. So, we do not want to be distinguishing this and this as 2 different words, okay, if you do the comparison. So, we want to convert all the text into lower case, and then we want to do the stemming part. Stemming is nothing but taking off these suffixes. Okay. And then lemmatization is a process which converts best into good. Okay. And then misspellings, if there is any wrong spellings available as part of the corpus, you replace that. Take out all the punctuations and then remove unnecessary white spaces, tabs, new lines, etc. Okay. Remove contractions. For example, isn't it is replaced by is not, and I would be replaced by this. Okay. Removal of scripts. If you are dealing with HTML corpus, you should be removing all the JavaScripts, form variables, and some XML tags and so on. Okay. So, I do not need any of those tags to be present as part of the content, because for me the content is important, not just the tags. In some cases, the tags provide you high level information. For example, if you have the bold, okay, and then some content, so it could be the title. So, you want to retain that in certain cases. So, you want to be very sure about what you want from the content and then write your pre-processing step. So, as I mentioned earlier, it is not an API that you can just use, okay, pre-process my content, it will do all the job on its own. No, you have to pick up your own pre-processing steps and then perform this. So, this is a very crucial step in any natural language processing. Okay. Okay. To give you an example of how we would do the pre-processing, I am just going to quote some small example. The example would be from physics. Okay. Can a machine solve problems all by itself by using the advances in machine learning artificial intelligence and NLP, and later explain it to the student in his or her native language. Okay. I'll just give one example of that. I hope it works. Okay. So, this is one application that reads, let us say, a problem of this type. An airplane accelerates down a runway at 3.2 meters per second and so on, right. So, this is a problem. I just want to post the problem, and the machine should solve this problem on its own by looking at the problem, finding out what are all the given values, okay, in terms of, here we have an acceleration, we have a time, and then it lifts off the ground, and then distance, determine the distance traveled before. So, we want the machine to read this natural language text, take out all the known quantities on its own like this. So, for example, from the problem it says time is given. So, it has normalized, look at this, right. As I mentioned earlier, the problem gives 3.20 m/s2. So, it understands that it could be meters per second square, it could be the acceleration. So, it translates that into the normalized form. The same fashion, 32.8 is the time, and then it, from the context it understands that it is starting, right, from the rest. So, the initial velocity is going to be 0 meters per second. Okay. And then it goes and then looks at all these values and then tries to find out which formula it fits into, and then replaces those values in the formula, replaces those symbols with the values, and finally it computes the distance, right. So, it computed the distance as 1721. So, assume that we have an application like this. Actually, this is an application that solves. You may want to try this if you want to go to this website. You can type some problems from the kinematics and then see whether it solves the problem. Okay. So, you can, it solves certain problems from the kinematics. Okay. It is a prototype, and I will warn you that it may not be able to solve every problem in kinematics. To show you an example of what we can do with natural language processing, I am just showing this. So, for me to do this task, right, I need to do some pre-processing. It is not enough if I just use the tokenization alone. It is not enough if I just do the stemming alone. It is not enough if I just convert this into the text into small letters. I need a lot more than that, right. So, let me show you what. So, these are certain tasks that the application does internally. It tries to find out whether it belongs to the kinematics or not first by looking at certain keywords that are found in the document, and then it creates the meta knowledge and start constructing that on its own. It tries to figure out some context. I am just giving a very high level overview. I am not going to describe the details of what it does. It tries to understand from the problem what are the context clues. The context clues are about the acceleration against gravity and so on. This is related to the problem that you find here. Okay, so not to the one that I had shown there. And then it tries to find out what are the known quantities given in this problem statement. It says the known quantity is only this, nothing else is given. Okay. So, it tries to figure out since it is taking off, it is going to be against gravity. So, it gets some acceleration due to gravity, and then the final velocity is going to be 0 because it jumps and then stops and then drops back to the ground, right. So, the final velocity is 0, it assumes, and then the height is given, the direction is the upward direction, and then tries to find out what the question is. So, determine the takeoff speed. So, using those phrases, it tries to find out what is the actual question. Okay. And then it says it is a direct question and it needs to find this. since it is speed, it also says this is a question mark a meter per second, and then it tries to find out based on what it found and stored as meta knowledge, and then tries to map this with a formula, and finally figures out there is a formula available and all the variables that are available could be fitted into that, and the speed could be found, and finally it finds the speed. So, for us to do this, we require various pre-processing steps. Okay, I need to remove the unnecessary new line that is available as part of that, and then remove hints. For example, certain problems will provide you hints: acceleration due to gravity equal to 9.8 meters per second square, right. So, it does not want to look at that and get confused. So, it removes that. Okay, it assumes that all those things that are happening is on the earth. Okay. And then it removes certain symbols that are available as part of the original text. A separate number equal to a sign by a space. For example, if x equal to phi, just write this as x equal to phi in some way. And then if there is a something like this, it removes those. Replace 10 power notation to e notation. For example, if somebody gives phi into 10 power minus phi, it replaces those into this form. Okay, so that is the normalization that we do and replacement that we do, and then fixes certain patterns in terms of the units and so on. So, if you look at this, there are so many pre-processing steps that are performed on this particular problem statement that we have in hand, right. So, before we really take the problem to the machine to solve it, these are the set of tasks that you have to do as part of the pre-processing. And as I mentioned, unless we understand what the corpus is all about in terms of its structure, in terms of the domain, it is not possible to do any of this. We could only do certain tasks, and it may not be really useful for the machine to use that. Okay. So, to give you some examples, this is the original corpus, the content that we have. Okay. I have given about 4 samples. Okay. So, you see the variations right here. Somebody will give you kmh, that means kilometer per hour. You need to standardize this notation. 25 minutes should be converted into seconds. So, you need to understand this is a time, right. And then the units and the number always occur in pairs in the problem statements that you will notice, right, in many cases. So, we need to be able to read them in pairs and understand that. And then the notations would vary. Some will say MPS, some will write EMS, some will write EMS minus 1. So, we need to be able to understand this when this occurs, and then based on some preceding words earlier, should really understand that unit is representing the velocity, and then convert this into the normalized form. Okay. And this is what is the normalized representation after the pre-processing step. I have one more which I am not showing here. You can see the pre-processed steps in this case. Okay. Here. Got it? If you want to do the same thing on a HTML corpus, for example, you have a help document that's available as part of the product, and it's about 20 different products that you have, and those documents are available as part of HTML text, right. And you want to do you want to provide quick help to the user by making it available in the cloud, and then you need to provide a search engine that searches through the document and brings the write content in front of the user by looking at all the HTML pages that are available as part of the corpus. So, for us to do certain NLP operation, so we need to convert the HTML into text, because this could contain lot of images, JavaScripts, form variables, all that, right. So, we need to convert that first into a text format without really losing the content of the source, and then do the case folding, remove scripts, tokenize, do the term frequency, extract the vocabulary, remove stop words, do stemming or lemmatization or both, and so on. So, this is for a task where we want to rank the documents that are coming in from the document repository. So, there we want to create a learning model which will try to rank the documents accordingly based on the user preferences. For example, if I use Solar, Solar is one of the open source applications that will help you in terms of indexing documents. It also gives you the list of documents available with respect to its own ranking. Okay, so it based on the frequencies of the words that are occurring, Solar gives you certain ranking in this order. But that ranking need not be always the right ranking, with respect to the user. User may think that the document that is third in this list could be the most important one. So, he would have clicked, or she would have clicked this several times during the search process. So, the machine should be able to read, understand the user intent as well, and then include that as part of the ranking, and then create a modified ranking. So, that is what we call as learn to rank process. We will talk about this in one of our classes later. So, in the learn to rank, I require all these frequency, vocabulary information, bigrams, trigrams information, and so on, in order for me to understand this, along with the query that is coming into the document, the user preferences, how many times they have clicked, and then the ranking from the Solar, the results of the Solar. I combine all of those and then create a new learning model, and then finally list that. So, in order for me to do that, my pre-processing steps are very different from what I had shown earlier, right. So, the reason why I am showing this is every pre-processing step and every is very unique to a given problem. So, that we should keep this in mind. Okay. So, if you take another problem, so study the problem very well, look at what you are really going to achieve in that application, and then accordingly pick up your pre-processing steps. Okay. So, with this I conclude the pre-processing, and then we will continue with the rest of the sessions later.